everyone. So today is 3.3 and it's another algebraic method of solving systems of equations. And you get to choose which one you like. I actually one time put that on a test. I said, what method do you like the best, the elimination method or the substitution method? Explain your reason why. And there was a guy named Clarence in my class that semester, and half the class put, I like substitution best because that's Clarence's favorite method. So I thought that was funny. Well, what's your favorite method? Well, that's Clarence's favorite method. So it could be yours too. We'll see what you think. So the problems in this section that we're looking at two lines and where two lines intersect one another, or are they right on top of one another, or are they parallel to one another? We're going to be looking at, towards the end of the book, we're going to be looking at different types of systems, and then it'll be necessary to choose which method. But the substitution method, when you just have lines, or the elimination method, when you just have lines, works equally well. And so there's going to be some other things where one method or the other, one method might not be possible. And so we'll save that from then. But now we're practicing both so that we can learn both of them. This substitution method, just like the elimination method, has a basic strategy. And that basic strategy is to first take one of your equations and solve it for x or for y, and it doesn't matter which one, and I put a box around it just so that I can find it later. And so it doesn't matter if you take equation 1 and you do this, or you take equation 2 and you do this. Or maybe it starts off for free like this. And so we're going to notice that's going to happen. Then what you're going to do is you're going to blend the two equations together by substituting one into the other equation. And how do you write that out, right? And so I said you write the other equation down and you substitute the boxed into the equation as you solved, and then you solve this, and then you get three different possibilities when you solve that. Now, when you substitute in, don't forget parentheses are implied. So I'll be practicing you with your parentheses. And then so then you'll have solved for one of the variables. You'll be able to once you solve, you'll have solved for one of the variables, and now you'll know x or you'll know y, and you can use substitution to find x or y, and the box is usually the other variable, right? The box is the easiest place to go back. And then you could check by substituting into both equations. Remember, people tell me that they don't like to check, and so they're not going to check. And if you don't check, you're guaranteeing that you will get some wrong, because no one is infallible on their arithmetic. And then it could be, though, that both variables drop out on you, and you didn't plan for that to happen, but when you substitute them together, all of a sudden you have no variables. And if you have a true statement like 0 equals 0, or 5 equals 5, or 10 equals 10, or there's some emails coming in. I told you 200 a day, right? So there's going to be popping in here. There's infinitely many solutions when you have a true statement and no variables. And you can check by solving for y, or check, because you're checking that both lines are exactly the same line. And remember, there's fancy notation for us to write this in. And so I'm going to help you with that fancy notation. And yes, it is necessary to write that in the fancy notation because we're getting credit for intermediate algebra here. And so we want to make, if both variables drop out but you have a false statement like 0 equals 7. Well, 0 doesn't equal 7. If it does, I'm going to give you no money and you bring over $7 to me and we'll be even, right? And so 0 doesn't equal 7. And so there's no solution. And you can check by checking that the lines are parallel with one another. So you could graph them here and check that they're the same line, or rearrange the equations so that you convince yourself they're the same line. And here you can solve for y, both equations for y, and check that they have the same slope but are not the same line, or you can graph them and see that they're parallel. So we'll give a try to some. So the first step, this is problem 6 out of your textbook, and the first step was to get one of the variables all by itself. And you notice that for free, y, x is not all by itself, y is all by itself in the second equation. And it doesn't matter if it's in the first equation or in the second equation. So I like to put a box around it. I kid you not, I've had someone raise their hand and ask, is it okay to put a circle around it? And the answer is, yes, that would be great. Anything, I just want to be able to find it again is all I want to do. And then you go to the other equation. This is equation 2, and this is equation 1. And so you start off with equation 1, and what you're going to do with equation 1 is you're going to write it out. But instead of where you see y, see where y is right here, you're going to put parentheses because we're going to substitute in for y. So right here, where we see y, we're going to put parentheses. And then we're going to put in here, right in here, we're going to be plugging in. Instead of y, we're going to be putting the value of y right in here. We're going to substitute it in. That's why it's called the substitution method. So minus 4x plus 1. And then you solve normally. And normally we learned in chapter 1, so we're getting pretty good at our normal solving, right? Because in chapter 1 we learned that the first step to solving an equation that has one variable in it, so there I now have an equation that has one variable in it, right, is to use the distributive property if you have it. Well, I have the distributive property, so I should distribute. Some people like to hang a 1 on there. So this is 4x, and then distributing here is plus 4x, and distributing here is minus 1 equals 5x. And you can start counting the amount of arithmetic that you do in these problems. It's a lot. That's why we have to be really, really accurate with our arithmetic. And then the next step is to combine like terms. Well, those are like terms right there. So 8x minus 1 equals 5. And the next step is to use add and subtract. So you notice that pretty soon, so I'm going to add 1, get them separated, right? And so pretty soon, I'm going to know what x is. And that's what this was saying. As you solve along, all of a sudden, you know one of the variables. Or all of a sudden, you have numbers on both sides, right, that are either the same or not the same. Well, I'm solving along, and pretty soon, I'm going to know what x is, right? 5 plus 1 is 6. And I'm going to divide, put my finger on x, right? And so, and 6 over 8, I hope I don't make an arithmetic mistake here. 2 goes into both of them, 3/4, right? And it's okay for your answer to be a fraction. There's nothing wrong with fractions. They start with an F, but not everything that starts with an F is a nasty word, right? And so fractions definitely are not. So we now know x, but we want to know y as well. And so that's where the equation with a box around it comes in handy, because the equation with a box around it is the easiest place to find out what y is. So you just come right back here and you plug in for x, right? Right where you see x, you plug in 3/4. And then all you have to do is do arithmetic. You don't have to solve anything. If I put it in here for x, I would have to do a little bit of arithmetic, and the arithmetic I'm going to have to do in algebra, I'm going to have to do, it's going to involve dividing by -1 at the end. And that's a really huge place that people make a boo-boo on. And so that's why you want to do it in the easiest place. And so, because that's where you save on your arithmetic, right? Now, with your calculator or without your calculator, 4's drop out, right? So this is y equals -3 plus 1. So you certainly don't have to have your calculator y equals -2. But if you're like, well, my arithmetic is not too good. Well, if your arithmetic is not too good, then I recommend that you do it by hand and by calculator. And so I don't know if that's like, you know, Paul Revere's Midnight Night Ride. What was that? 1 if by land, if 2 if by sea. I don't know. By hand and by calculator. I don't know. Maybe they're not the same. But I got -2, right? So now I know, well, I did it 2 ways and I got the same answer. Now remember that your answer is an ordered pair. And so if I just circle these two answers and I go on to the next one, I have not shown that my answer is an ordered pair. And some people say, well, it's not very hard to write it as an ordered pair. Well, I get people writing it backwards all the time. And so it matters what order that you write it in. And you do need to write it as an ordered pair. That's the answer to a system of equations, is an ordered pair. So if you write it as this and this, you haven't finished the process. You're almost there though, right? So hopefully I haven't already done that. And I'll look at all my notes to make sure, right? And so anyway, so there's my answer. But you want to make sure that your answer is correct. And so you should always check. So people always ask me, do I have to check? And I don't know what to say about that. I mean, if you want to get it right, you should always check. That's what I want to say. And that's the goal, right? Is to get it right. And so everyone makes mistakes. Like me, I ate a chip before coming on my video, and that's a mistake. And now I don't have any water or any tea or anything to drink here, and I'm gonna choke to death on my chip. And so this ought to equal 5, and if this doesn't equal 5, so I'm plugging into equation 1, then I know I have a mistake. So 4, and you can do it with your head too, right? You can say here, well, those will be 3, and that would be plus 2, and yeah, 3 plus 2 is 5. So certainly you can do it by head or by calculator, either one on that. I recommend both, actually, to be honest with you. I try to do things with both in an effort to have less mistakes. And so I put a plus there, and so, but you could have also put subtract and then parentheses of a negative. That would have worked just as well, right? And so now I made it look just like it was. And so yeah, I do get 5. So that worked out. Now I want to do equation 2. You should check into both equations, because if you've made one mistake, then it'll work in one equation and not the other. So remember what y was. It was -2. X is positive 3/4. By head or by calculator, right? And so by my head, hey, that's -2, but I'll make sure with my calculator and see what we get there. So that's -4, and so, and then 3/4 here, 3/4, and plus 1. And so putting it in, yeah. So we did get -2 equals -2, and so that tells us that, hey, that is a good answer. And then we can do the next one, right? And so this one, again, is solved. It's ready. It's solved for y, so it's ready to do substitution. It can be solved for either x or y. Just coincidentally, these were both solved for y. And I'm going to put a box. I like to put a box or circle or put stars around or whatever to show myself the one that is my substituting in. Then you take the other equation. Since this is equation 2, you take equation 1 and you write it down. 10x plus 2y equals -6. And where I see y, I'm going to put parentheses. So 10x plus 2 times parentheses, because that's what I'm going to substitute in for, is y. So instead of y, I'm going to put what y is equal to, what y is equivalent to, which is -5x. I'm going to substitute in that for y. Then I'm going to do the arithmetic, and I'm going to solve it. So I notice here, solve it like I would in chapter 1, right? So that's why they gave us problems that look like this in chapter 1. And everyone always asks me, hey, is your first step just to multiply those together? And yeah, usually I have distributing, but this one's not a distribute, right? Because it's just, this is a single term. So it's just multiply. But yeah, that's what you do first. So 10x plus, if you like, -10x, or you could have put -10x, whichever one floats your boat. And then 0, right? 10x, take away 10x is 0. And 0 doesn't equal -6. And so this is, because this and this are both numbers, no variables anymore, this is no solution. And then I get the choice on how I check it to make sure I have just used an algebraic method to solve it, but I want to check it to make sure that I'm right. And I don't have things I can plug in, right? And so like I did over there. And so you have to have, I mean, there's different ways of checking whichever one you want to do. You could graph them both, and that would work, and show yourself that they are parallel lines, right? A better way than graphing them, because remember how your lines can look parallel and not really be parallel, and so is to do the slope, is to use the slope. So take equation 1, and I want to rearrange it for y, because when I do, I will be able to see the slope. So I want to solve for y. So I'm going to take away 10x, take away 10x. I hope this is getting kind of cookbook, because we did it so often in the last section. I like to put the negative 10x first, so negative 10x minus 6. Then I'm going to divide by 2. I mean, it gets where it's like the same, right? And so, I mean, the same process. So negative 5x minus 3. Okay, so here I can see my slope of line 1 is negative 5. But it crosses the y-axis at negative 3, right? The y-intercept. And so my other equation, equation 2, I don't have to solve it for y, it's already done. So that's free. I don't have to do any work, it's already solved for y. And I can see that the slope is negative 5. And the b here, that's where it crosses the y-axis with negative 3. The b here is 0, right? It's crossing at the origin, because it's plus 0 would be here, right? And so they're not the same line, right? They have the same slope, but they are not the same line. And that's what things that have no solution are. They're parallel to one another. They have the same slope, but they're not the same line. Okay, so this is number 20. And they're asking me to use substitution on it. And it's not set up to do substitution. And so they want me to rearrange it so that I can use substitution. And so I get the choice of solving equation 1 or equation 2, my choice, for x or for y. And I want to do the easiest thing possible. So anything that has a coefficient is less easy than something that doesn't have a coefficient. So this has a coefficient of 2 or negative 2, depending on how you want to think of it. 3 or negative 3, depending on how you want to think of it. I think negative 3, because I would write that as plus of negative 3y, right? So anyway, having a coefficient makes it less easy. So I don't want to solve for y because it has a coefficient. I don't want to solve for y because it has a coefficient. Whereas this does not have a coefficient, neither does that. So solving for x in either equation would be great. So I'm going to solve for x in the first equation. That's flip a coin, right? Sing a song about flipping a coin, right? And so I'm going to solve for x. I'm going to get x by itself. That's my thought. I'm writing out my thought. Usually I just think my thought. I don't normally write it. All I have to do to solve for x is add 3y. Add 3y. Your choice, whether you put the 3y before the 5 or after the 5. I'm going to put it before the 5 because that's what I'm more used to, but your choice on that. This is my equation 1, right? And this is now solved for my variable. So I'm going to put a box around it. I'm going to box it good, right? Circle it, whatever you want. Then what you do is you take the other equation, which is equation 2, and write it down. X minus 2y equals 0. And right where you see x, you're going to put parentheses. And you're going to plug in what this equation says about x. So this equation says that x is equal to 3y minus 5. So right in here, you're going to put 3y minus 5. And so when the dust clears, right, I have parentheses, but there was no coefficient out here that says distribute. So really I'm distributing a 1, which so it doesn't change it, so I don't really need those parentheses there. If I would have had a coefficient, I would have needed it, and so I was ready if I needed it. I'm trying to solve for y, and I have 3y take away 2y is y minus 5 equals 0. And so I can see that just by adding 5 to both sides, all of a sudden I'm going to know y. And I'm like, hot diggity dog, I know what y is. And so I'm all done, right? I should go on to the next one. No, remember it was a system, and systems have ordered pair as a solution, and that's not an ordered pair, right? An ordered pair, it looks like an x comma y, and so I right now know what y is, and I want to know what x is as well. And the box is the best place to go back. The box is the easiest place to go back, but both will give you the answer. So I want to put in to the boxed equation that y is 5. That's why I boxed it, so that I could find it when I got here. Because the best place to go back is, and then I look up there, oh, I have a box around it, right? That's the best place to go back. And so when I put in y is 5, all I have to do is do the arithmetic, where here I'd have to do, if I did it in equation 2, I'd have to work harder if I did it in the equation that didn't have a box around it. So this is going to be x equals 15 take away 5, which is 10. So our answer is 10 comma 5. And we always want to check our answer. Somehow or another, we want to make sure that we did not make an arithmetic mistake going along. I make arithmetic mistakes, and I have to correct my videos when I've made an arithmetic mistake in them. Very rarely do I make an arithmetic mistake in class, because in class there'll be someone that will say to me, hey, you just added those two numbers wrong, or whatever, you know what I mean, give me a, someone out of 30 will give me a heads up that I'm making a mistake. In my videos, when I make a boo-boo, somebody will send me a nice email telling me, hey, you made a little boo-boo there, and then I go try to fix them, is what I try to do. And so here we have 10 for x, and 5 is y. But you try not to have arithmetic mistakes. If you don't check, you'll be riddled with them, right? And so 10 take away 15 is negative 5. Check. And then equation 2, I want to make sure it works in equation 2. X minus 2y equals 0. So x minus 2y equals 0. So x is 10 and y is 5. 10 take away 10 is 0. So it worked. So we did a lovely job on that. So we did wonderfully, and everything was cool there. And again, I had for in class the solution that was infinitely many solutions, and so I want to make sure that I do one, because and so I'm going to take this one right out of the problems from your textbook, the examples, and you can go watch the example if you like as well. It's all good. And so this is example 5 in your textbook. Example 5 in the textbook. So this is 4x plus 2y equals 8. I have y equals minus 2x plus 4. Okay. So I would be hoo-de-doo. It's a system of equations. Not expecting anything special, right? Because I wanted to have an example of each kind. And I noticed that I had those as the first problem we did in class, and I went around and helped people. Now I'm going to do it here on the video. This is now first solve for y. So I'm going to put a box around it. It could be solved for y or for x. It doesn't matter. Then you take the other equation and you write it down. You get where you don't have to be as stiff with it as I'm being here. But I'm being stiff with it. Remember, I'm going to replace y, so that I don't make a mistake, right? So plus 2, remember parentheses are implied when you substitute, equals 8. And we're substituting in for y, negative 2x minus 2x plus 4. So, solving strategy, right, from chapter 1, distributive property. So I got to do that first. Combine like terms, right, after that. So minus 4x. Right? I wouldn't be expecting anything is going to go wrong. Anything is going to happen silly or funny or anything like that. But all of a sudden, the next thing I know, I had eliminated y. Notice this equation doesn't have x in it. I had gotten rid of y. And next thing I know, wait a minute, there's no x's in the equation either, because 4x take away 4x is 0. And then I get a true statement, 8 equals 8. And that means it's IMS. There's infinitely many solutions. And they write their answer quite fancy. And you should write your answer quite fancy as well. And it's always the same. The set of ordered pairs such that, and then you get to choose this one or this one. They're the same line. So either one of them will do. Some people will say, well, put the one that you put a box around there because that's in slope-intercept form. Other people will say, put the first one because it's in standard form. Other people will say, I don't care which one you put. They're the same line. And so there's our answer. So there truly is our answer here. Now we haven't checked to make sure that our answer is correct. And we want to make sure that our answer is correct. And ways that you can check is that you can graph both lines and show that they're right on top of one another. That would be a way of doing it. Get convenient points or use a slope in the y-intercept or whatever you want to do. That would work out. The other thing that you could do is that you could just rearrange the lines so that you could see that they're exactly the same. And so since this one solved for y, I think I'll take that one and I'll solve it for y as well. So this is my check. If you don't check, you of course will have it wrong sometimes. And if when you're checking, if it doesn't come out to be the other, when I solve for y, if it doesn't look just like that, then I'm going to know that I have a mistake, right? So solving for y, I'm going to take away 4x. I'm putting it in slope-intercept form. And I'm going to write the x first. That's my habit. Simplifying that up, right? You notice that they're the same darn line. Equation 2 was y equals negative 2x plus 4 as well, right? They're the same darn line. That's what happens when there is infinitely many solutions. They were the same darn line. So if I rearrange them, I can see that they're the same darn line. Okay, so we did a lovely job on that. And I'm going to write myself a note. Add example 5, right? And so you had to jump onto your own paper if you were a printer, and I apologize about that. And here is our last example of 3.3, and it's a word problem, right? It says, it's from your textbook, Pat runs a small company that produces custom Blu-ray video discs. The daily cost and daily revenue for the company producing the Blu-ray discs are shown in the following figure. The daily cost for duplicating X discs is given by y equals 6/5 X plus 20. The daily revenue, the amount of money he brings in each day for duplicating X discs, is y equals 1.7 X. So this equation's got a fraction in it. They got another equation that's got a decimal in it. And then they said that they graphed them, right? So they graphed both of these. And they said that one of them was the cost, the daily cost. So this one right here is the cost. And this one right here is the amount of money that he brings in, the revenue, right? Now, one thing I'm going to tell you about revenue, is that that's how much money you brought in, not how much profit that you have. And so let's say that you're a person that sells these discs, right? And you bring in $1.70 per disc. That's what's going on here, 1.7, right? $1.70 per disc. But it costs you something to make that disc. So you didn't make $1.70, even if you feel like you have $1.70 after someone buys a disc from you, right? Because it costs you something, right? And so anyway, so the first question they ask here is Pat, or statement, I guess he starts off with, Pat will break even when his cost and his revenue are equal. So that's when he neither loses money nor makes money, when he breaks even. And so, and then it asks, how many discs does he need to produce to break even? So if he was just going to break even, and so here they've graphed for me very nicely, right? And do you guys remember the graphene method that we did in 3.1? Well, we're looking at where they intersected. And so does it look like to you guys too that they're intersecting where X is 40, right? And they asked how many discs, and the videos made per day, the discs made per day. And so for part A, it asked how many discs. Discs are X in this case, right? So X is 40. So 40 discs, right? Part B. Pat will incur a loss when his revenue is less than his cost. If he produces 30 discs in one day, will he incur a loss? And so they just want me to look at this graph. And so I'm going to go halfway between 20 and 30, 20 and 40. That's where 30 will be. And I want to look here and see if the revenue is lower than the cost. And can you see that it is, right? The line here. So our revenue is lower for everything this way. And so all of this is where he's making a loss. So he's in this business, but he's having a loss. And so if he produces 30 discs in one day, will he incur a loss? And the answer is yes, he will, right? Because his revenue is definitely less than his cost. Part C. Pat will make a profit when his revenue is larger than his cost. For what values of X will Pat make a profit? So we want to make a profit. And right here is where we break even. And over here, our revenue is less than our cost, so we are actually having a loss. But over here, our revenue goes higher. Here's our revenue going higher. I think that's a song too, right? And then lower over here is our cost. So anywhere this side, this way, is going to be a profit for Pat. Now we don't want to include 40 because 40 was breaking even. So we want it to be more than 40. And so I'm going to write it like this, that X is greater than 40 is how I'm going to write it. And so, or I could say more than 40 discs. Now, my graph goes up to 100, and it seems to stop at 100. And they didn't tell me, does it continue past, or does something, awful happen at 100 and it goes, they didn't say on that. And so I'm just going to assume that things just continue bright and happy, and just getting more and more. Why does the graph appear in quadrant 1 only? And so that's the next thing that they're asking us. And what they're talking about here is that if I extended this out, right, then over here would be negative 20, and here would be negative 40, And down here would be, let's see, they were counting them by 20s, right? So 20, negative 20, and negative 40, right? Like that. And so this is, here is quadrant 1, and here is quadrant 2, and down here is quadrant 3, and over here is quadrant 4. But they didn't bother having that, right? And so why not? Can you think of why? So for one thing, to be in quadrant 2 or quadrant 3, you would have to produce a negative amount of disks per day. And you can't do that, right? You produce none as a possibility. You produce 1, you produce 2, but you don't produce negative amount of disks, right? And so the number of disks, the number of disks made, videos made, needs to be non-negative. I could have said positive, but I wanted to make sure that it was okay to be 0 as well. 0 is not really positive. So that's why I said non-negative. And then what about going over here and then down this way into quadrant 4? So that handles why you can't have quadrant 3 and 2, right? 2 and 3, right? Because then your x's, which stood for the number of disks you would make a day, would be negative. But over here in quadrant 4, wouldn't be negative on your x's, but it would be negative on your money, right? And that actually can happen sometimes to a company, right? You've probably heard of companies losing money, and that certainly can happen. Now, I can't have, well, you know what? This is cost. It's not profit, people. So, or me, I should talk to myself. Donna, this is not profit. This is revenue. Can you collect negative amount of money a day? And the answer is, well, I mean, is that, when I collect negative money, is that selling the disc to a person and giving them the disc but not getting the money from them? So I think they're saying that you can't collect negative amount of money because that's your revenue, is your money coming in, right? And that money coming in can't be negative. What about cost? Well, if I produce something, it's not going to cost me negative amount of money. I mean, as far as I don't save money or anything like that when I produce something, it costs me something, right? And so I'm going to say that cost and revenue, oh, how do you spell revenue? I don't know. Can't be negative. Right? So they need to be non-negative as well. Okay, so we did a lovely job on that. Really wasn't math too much there, right? I mean, they weren't really asking me math questions per se. They were asking me to interpret the graph. I didn't even have to whip out and work with these awful fractions. I was just able to read things off the graph, you know what I mean? And decimal there. So, and those weren't awful ones anyway. Those are really sweet ones. Okay, so that's that video.